do in our first lesson. We're not going to get into new material just yet. I want to review Chapter 8 a little bit more, and then I also want to go over the test, some of those answers there. Now you'll notice that a lot of the tests we didn't do because we didn't get into lesson 8.6, and we may get into a little bit of that in this lesson. But I do want to go over those answers on the test, and your assignment for today will be to do the test corrections. Again, it wasn't counted as a test, it was just counted as a quiz grade. But I do want to see those corrections, and I'll have an assignment pad up for you to turn that in. Let's just review Chapter 8 though. So 8.1. We were talking about products and powers. We had our products property, which says multiplying the same base, what do we do to the exponents? Well, we add them. So whatever A and B are, we add those together because we've got a common base of x. And we're multiplying those. That does not apply if this multiplication sign right here is an addition or a subtraction sign. We must be multiplying same base. Then we can add the exponents. We also learned that a power to a power, we do what? Power to a power, we multiply. So we would multiply A and B together. Power to a power, we multiply, multiplying same base, we add the exponents. So let's do an example problem real quick here. Negative 2m to the fourth power n to the third power outside of the parentheses times 1/6 mn squared, and all of that squared. Go ahead and do this one with me on a separate sheet of paper as well too. And again, feel free, go ahead and move on if you know how to do this, but if not, follow along with me. First thing I want to do is look inside my parentheses. Do I have multiplying same base inside of my parentheses? Well, no, I don't. I've got an m and an n, but I do have a power to a power. Where do these powers go? Well, they have to be distributed to every single number or letter variable inside the parentheses. So the 2 has to go to the 1/6, the m, and the n squared. So here we go. Negative 2 has to be cubed. M to the fourth has to be cubed. N has to be cubed. Well, that one's easy. That one's just going to be n. So I've got this first set over here complete. Let's get these ones over here. 1/6 has to be squared. That square applies to every single thing inside. That m needs to be squared. N squared also will go to the second power. Okay, let's simplify. Negative 2 cubed. That's negative 2 times negative 2 times negative 2. That's negative 8. Oh, power to a power, we multiply. So what's 4 times 3? 12. So it's m to the 12th power, n cubed. There's our first set there. What about 1/6 squared? Well, that's 1/6 times 1/6. You can do that in your head. That's 1/36. And then we've got m squared. And then power to a power, we multiply. So that should be n to the fourth power. Now, I can simplify even more because what operation am I doing with all of these? Well, I'm multiplying. Negative 8 times 1/36. Well, that's negative 8/36. We'll come back and simplify that in a minute. M to the 12th power. Hey, I've got same base right here. When we're multiplying the same base, what do we do to the exponents? We add them. Again, if I had an addition sign right here in between these two terms, could I combine into the 12th power and m squared? No, 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 I cannot. I can only do it because we are multiplying all of these things together. n cubed, and into the fourth. I'm multiplying same base there. I can add the exponents as well. Let's simplify. What is negative 8 over 36 simplified to? Well, I have the greatest common factor between these two is 4, so negative 8 divided by 4 is negative 2. Over 36 divided by 4 is 9, so I've got negative 2 ninths times n to the 14th power times n to the 7th power, and that is my final answer. Let's keep moving. Let's see if I can pull up a new document here for lesson 8.2. Again, we're just reviewing topics here. In 8.1, we had our product rule. We had a power to a power multiply. Now we are moving on to our quotient property, which says if we are dividing by the same base, we subtract our exponents. So dividing by the same base of x, subtract a minus b. Let's do an example real quick. I have 24 x squared, y to the 6th, z to the 7th, all over negative 8x, y squared, z to the 5th. All right. Can I simplify my numbers here? What's 24 divided by negative 8? Well, that's just negative 3. I am dividing same base of x squared and x. So dividing same base, I subtract my exponents. Again, I've got y to the 6th and y squared, so I can subtract those exponents there. And lastly, I have common bases of z where I'm dividing, so I can subtract these exponents as well. That will get me negative 3 x to the first power, y to the 4th, and z squared is my final answer. And that is it for the most part for, let me go over one more topic real quick. If I have a fraction to some power, that power is going to go to both the numerator and to the denominator. Just like we said in the previous lesson, if I have a power, it's going to go to everything inside of the parentheses. So for example, if I have 2 over a squared, that exponent of 2 is going to go to the 2, and it needs to go to the a as well, a power to a power. So 2 squared is 4 all over a squared. And here's just a review as well too. What if I wanted all of the exponents, all of the variables and the exponents in the numerator? Well, a squared is not in the numerator. How would I put a squared in the numerator? Well, I would need to negate the exponent. So it would be 4a to the negative 2. That would be putting a squared in the numerator right there. And vice versa, if I got a final answer of 4a to the negative 2 and it said put all exponents positive, how would I make a negative exponent positive? I would need to flip it back to 4 over a squared. All right, let's keep moving on. 8.3. We started doing a little bit more scientific notation. You've done some of this in the past. So it was review. A lot of it was, but remember, when we put a number in scientific notation, it can be equal to 1, but it's got to be greater than 1 or equal to 1, but it has to be less than 10. So the number 900 is not in scientific notation. The number 900 would need to be made to 9 times 10 to the, here's my decimal here, so I move it 2 places to the left. So 900 in scientific notation would be 9 times 10 squared. Again, a decimal of 0.9, that's not in scientific notation. I need to move that decimal to the right 1 place. My number is 9. If I move the decimal to the right, it needs to become a negative exponent right there. Probably the harder problems in this lesson were when we were adding or subtracting, and we had, I'm trying to remember if it was a quiz or if it was the test where we had problems like this. So let's do an example. If I have 5.4 times 10 to the 5th, and I want to subtract 4.7 times 10 to the 5th power, we'll start off with an easier one right here. What do I notice is the same? Let me ask you this. Am I multiplying this term and this term? No, I am subtracting them. So do I have a same base? Can I add these base 10 plus, can I do this and add these two together? Because I'm multiplying same base. No, you're subtracting them, so I can't add these together. Remember, what is common? What is common in these two terms? Well, 10 to the 5th is common. So can I divide out a 10 to the 5th and a 10 to the 5th here? Can I pull that outside the parentheses? Well, sure I can. 10 to the 5th divided by 10 to the 5th, I'm left with 5.4 minus 10 to the 5th. Oh, that's 1, so I'm just left with 4.7 over here. What's 5.4 minus 4.7? Well, that's 0.7. And I don't forget about your 10 to the 5th out here. So 0.7 times 10 to the 5th power is what these two terms subtracted would be. But is that in scientific notation? No, I need to change 0.7 to a number between 1 and 10. So that's 7 times 10 to the, all right, I moved the decimal to the right one place. If I move it to the right, that would be a -1 power. But I also have a 10 to the 5th power there as well. Now, multiplying same base, add the exponents. -1 plus 5 is +4. This is my final answer in scientific notation. Let's come up here. What if we were subtracting terms, but a lot of times we are not going to have the same exponents? 5.4 times 10 to the 5th minus 4.7 times 10 to the 4th power. All right, I could pull out a 10 to the 4th power, but I would still have a 10 power left over. So let's come over here and let's change that. Let's leave 5.4 times 10 to the 5th power alone for right now. And let's change this 4.7 times 10 to the 4th. Let's change that to 10 to the 5th. So if I were to change this one to 10 to the 5th power, what would be happening to this 4.7? What would I need to multiply 4.7 by in order to get 10 to the 5th? Or excuse me, what would 4.7 change to? Well, I'm only moving it one decimal place, but is it going to move to 0.47 times 10 to the 5th? Or is it going to be 47 times 10 to the 5th? Remember, we're not changing this answer. We're not changing the number right here. If we were to draw 4.7 times 10 to the 4th power out in standard form, the number would be, let's see here, move that over 4 places, 1, 2, 3, 4. The number would be 47,000, but that's not in scientific notation. We're dealing with scientific notation right now. But 4.7 times 10 to the 4th. I want this to be 10 to the 5th power. So without changing 47,000, would it be 0.47 or would it be 47? Which one would it be? Hopefully you said 0.47 is what we would change it to. Let's check our answer. If I were to make 0.47 times 10 to the 5th in standard form, I would move this decimal to the right 5 places. 1, 2, 3, 4, 5. Yep, that would give me 47,000. So I moved the decimal in the right direction. Now I've got 10 to the 5th. In both of my terms, I can pull out a 10 to the 5th, and I get 5.4 minus 0.47 left over inside when I divide out 10 to the 5th by both terms. Don't get rid of the 10 to the 5th power. What is 5.4 minus 0.47? Hopefully you got 4.93, so let's write it in scientific notation. 4.93 times 10 to the 5th would be your final answer. I'm going to go ahead and give you a break for right now. Check out the next video for the rest of the lessons and for the test corrections coming up.